Most students are already familiar with the concept of angles. However, it's important for us to go through the terminology just to make sure we have the right ideas and the right words. So, what is an angle? Well, an angle is what you get whenever you have two line segments that intersect. We call this point right here the vertex. And usually when we're talking about measuring an angle, we're measuring from one side to another. So in this case, we'll go this way. The from side is the initial side. And the to side is going to be the terminal side. And this is just language that gives us from one side to another. Typically, we'd call the angle something like theta. Theta is a Greek letter. And so when we're measuring an angle, we're measuring how much rotation it takes to go from one to the other. So from the initial side to the terminal side. Now, in general, those angles can appear anywhere in the plane in any orientation whatsoever. We sometimes call them geometric angle when we're just saying, okay, the measure of the angle between these two things. However, there's a specific way of orienting things on the plane that's particularly useful for trigonometry. And this is known as standard position. So standard position, when you have the xy plane like this, the initial side is along the positive x-axis, and then the terminal side is wherever it happens to be. When we have angles in standard position, it makes sense to talk about positive and negative angles. So positive angle is an angle, positive angle. A positive angle is an angle which rotates in the counterclockwise direction. So from here to here in this direction is a positive angle. Negative angle will rotate in the clockwise direction. So from here down to here. And this will become important later on as we start talking about more trigonometry stuff to know whether we're talking about positive and negative angles and sort of how everything is oriented on the plane. There are two units that we use to measure the size of an angle: degrees and radians. Now with degrees, most students are familiar with this, the idea that if you go one full rotation, that's the same as 360 degrees. Now, why 360? Why is that the number? It turns out that this is a number given to us by history. It has its usefulness in that this number has a lot of divisors, meaning that I could divide this by 2, 3, 4, 5, 6, 8, basically a lot of small numbers and not end up with the decimal. So most students know that a right angle is 90 degrees. And it would have been grossly inconvenient if this number were like 73.8. It just wouldn't work well. And so for convenience, this number 360 degrees has been chosen because it has all these nice divisors. Now, this is both good and bad. It's good in the sense that it works. Practically speaking, this gives us nice numbers for a lot of these angles, and it works. It's bad in that this number 360 is still arbitrary. It could have been 720, and it would have even more divisors. So why this one instead of something else? Again, that's just sort of given to us by history. So what mathematicians want to do is they want to try to take this idea of an angle and measuring the angle and relate it back to straight geometry rather than using arbitrary values like this. And so the way we do this in math is we say, okay, well, here's an angle. And let's imagine we go out some radius r and create a circular arc like this. The distance along that arc we'll call s. And this is our angle theta. And what we're going to do is we're going to define theta to be s over r. Now this may seem strange at first. This why this arbitrary r and just why this distance here. Well, this gives us the same concept. When s gets bigger, the angle gets bigger as long as we keep the same radius. And so this at least captures the idea of bigger angles have bigger numbers. The fancy part about this is that this actually works regardless of what value of r we use. The same angle for different radii. So instead of using the whole thing, if we use either of these smaller angles here, the ratio of s over r remains the same for the same angle. And so this is what we mean by having a geometric definition. It's dependent only on the shape of the geometry and some geometric facts about the shapes, and not dependent on some arbitrary value like 360. And this is, when we go on later on, we'll actually see that this gives us a lot of formulas that are nicer looking and easier to use and easier to understand. And so we'll get to that in a little bit.